Today we're going to talk about collections. Arrays, linked lists, stacks, queues, trees, sets, and maps are some of the most common data structures in Java. Today will be a quick introduction. Let's start with arrays. Arrays are one of the most straightforward and widely utilized data structures in Java. They represent a collection of elements of the same data type stored in sequential memory locations. You should be familiar with the syntax in this example for creating an array of integers. Now let's run through what this looks like, where we will create an array of numbers and print them sequentially. So let's run through this and see what the output looks like. And that's as we would expect. A stack is a data structure aligning with the last in, first out concept. Stacks find common application in managing function calls, facilitating undo operations and parsing expressions. So let's take a look at a stack. We have an input of the word hello, and we will then push each character of the string into the stack, and we will pop each character from the stack and build a reverse string. Let's take a look at that output now. And it's as we would expect. Here it shows each letter in the input string, and here we've printed the string in reversed order. Unlike stacks, queues adhere to the first in, first out principle. Java provides various queue implementations. Queues play a crucial role in tasks such as organizing jobs in a queue and scheduling processes. Let's take a look at an example here. First, we will create the queue. We will add 4 customers to the queue. We will process them sequentially and take a look at the output after we've served all the customers. Let's take a look at this output. And it's as we would expect. We've added 4 customers to the queue, and as each customer is processed, the information is printed to the console, and then we see the queue after serving all the customers. Now let's take a look at trees. Trees are hierarchical data structures with a root node and branches leading to child nodes. They're useful for applications like searching, sorting, and managing hierarchical data. Let's take a look at an example. Here we're going to insert 4, 5, 6, 7 different elements in somewhat random order, and then we will traverse through the binary tree and print them in order. Let's take a look at that output now. And as we would expect, we've input the elements in random order, and they have printed in order. And the output is as we would expect. This is a little more complicated. We have created a binary tree class object, and you can see the methods and how we use recursion to put them in order. And then we also have a node object. The combination of these classes is used to give us the output that we desire. Next, we look at sets. Sets are particularly useful for storing unique elements and can be used to perform operations like union, intersection, and difference. Here we've created a set, and we will add 4 elements to the set, the last of which is a duplicate. And then we will print the set with the duplicates removed, and then we will create another set, add to it apple and cherry, and we will print the union of those, and we can see where the duplicates are removed as well. We will then print the intersection, and then finally the difference. And let's take a look at what that output looks like. And so here we have it. We have printed the first set with the duplicate removed. We've printed the second set. We've printed a union of the sets where the duplicates are removed again, and an intersection of both sets, which in this case it's apple. And then the difference of the sets, what it does is it prints just the first set. The second set is removed. Maps serve as key value data structures, enabling the storage and retrieval of values associated with unique keys. In Java, HashMap and TreeMap are extensively used map implementations. HashMap ensures swift access to values based on their keys, while TreeMap organizing keys in assorted order. Let's take a look at an example of this. We have a text string that has several words, some of which are in here more than once. And what we want to do is we want to split this text into its individual words and then count the occurrence of each word. So let's take a look at that output now. And this is as we would expect. The word beautiful occurs once, the word world occurs twice, the words everyone, in, and this occur once, and the word hello occurs twice as well. So here you have an example of a map and the output, and it is as we would expect.